Check one. Right. Good evening, everybody. Back again with our MCQ night session. Today we'll have to start with 2019 paper question. 2019 O-level paper MCQ question 11 to 20. That means the second set of MCQ is there for us to finish off today. Before we start, confirm from your end. Is all the DOs perfect? Working well. Perfect. Huh. A lot of things are there to discuss. Second set of MCQ in 2019. Right. I'll directly start. Lot of things are there to discuss. Question 11, a gravity comparison question is there. Question 15, VT graph question is there. Question 17, mole comparison is there. Question 18, resistor problem is there. I will do like this. First, I will discuss 18th question, resistor combination question. Then I will discuss a 17th question, mole comparison. Then I'll discuss 15th question, VT graph. Then the gravity question. Fourth question. That's the order. So a lot of things are there for us to discuss a bit deep today. 2019 paper is like that. There are a lot of things for us to discuss deep today. From your end, get ready with your review book. Get ready with your review book. And send me ready from your end. Lot of big things are there to discuss. Get ready with your review book. Send me ready from your end. And now don't sit like this. Some fellows are still sitting like this. Properly sit. Properly sit. Align yourself. Right. Let's start the session. There you go. First, I'll discuss the resistor question. Resistor question. What's the question telling us? There are 3 wires of equal length with uniform resistance. Right. Illustrated below are 3 instances in which the 3 wires are connected between the point X and Y in the same circuit, where The first wire is connected as it is. Second wire is cut into two equal parts. And the third cut into three equal parts. Assume the voltage of the battery stays constant. So first put the things to the mind. What are they telling from this question? What are they telling? There are three wires it seems of equal resistance, equal length. Three wires of equal length, uniform resistance. So they are connected in three different ways. First one, connected as it is. Second one, they are cut into two and connected using parallel connection. Third one, they are cut into three and connected using parallel connection. They are asking in which connection brightness of the bulb is high. First tell me, Lamai, for the brightness to be high. For the brightness to be high. For the brightness of the bulb to be high, what can you tell about the current flow? Current flow should be high or low? And current flow should be high. For the brightness to be high, current flow should be high. For the current flow to be high, resistance should be high or low? Resistance should be high or low? Guaranteed low. Resistance should be low. That means equivalent resistance should be low. They are asking in which instance brightness of the bulb is highest. For the brightness to be highest, resistance, equivalent resistance should be low. So your job is you need to find out of these three, which one has the low, which one has the lowest resistance. That's your job. You need to find out of these three, which one has the lowest resistance. Why? Lower the resistance, higher the current flow, higher the current flow, higher the brightness. So you need to find where are the lowest resistance. Now some of you would have done this question logically. But I recommend this, when you have a question like this, try to put some values. Solve with values. When you solve with values, Lama, you exactly know where the resistance is lowest. Otherwise, when you try to guess or think or logically do it, logically also you can do. Once when you practice about 5 or 6 questions in this pattern, you will understand the logic behind this. That one also I'll tell you. But more than logical thing, when you, now let's take in the exam, you got a question like this. You are trying to think and do this. More than thinking and doing it, quickly put some values, try to solve and find out where you get the lowest equivalent resistance. From there, you can 100% be confirmed, this setup lowest equivalent resistance. That we try to do. Right. We'll put some values. Now, what are they telling? There are three wires of equal length, uniform resistance. No? I'll take the wire is 6 ohm. Wire is 6 ohm. Just imagine. If you don't like 6 ohm, you take some other number. I'll put 6 ohm. Illustrated below are three instances in which the three wires are connected between the point X and Y in the same circuit, where first wire is connected as it is. First wire connected as it is. This is ohm. Second wire is cut into two equal parts. The full resistance is 6 ohm, cut into 2. Then you all tell me, one will be how many ohms? 3 ohm. One is 3 ohm. Mathematical thing, 3 ohm. And the third cut into 3 equal parts. 3 equal parts means one will be how many ohms? One will be how many ohms? 2 ohm. 2 ohm. I just randomly selected 6 ohm. There is no any reason behind it. I just randomly selected 6 ohm. If you don't like 6 ohm, you will select someone. You select something else. You can select whatever the value you want, because we are going to put the value. At the end, we are just going to compare. They are not going to value. No? We are just going to compare. So for comparison, you just put some values and see. Now here, total equivalent resistance is directly Total equivalent resistance is directly 6 ohm, no doubt. Directly connected. Here, two resistors in parallel. I have taught you all the shortcut. Two resistors in parallel. How do you find the equivalent resistance? What's the shortcut? Two resistors in parallel. How do you find the equivalent resistance? Can you remember the shortcut I taught you? 3 ohm, 3 ohm. What's the shortcut? Multiplication 3 into 3 multiplication divided by addition 3 plus 3. This is only for two resistors in parallel. So many times I have taught you this shortcut. So equivalent resistance, one shot you can calculate multiplication 3 into 3 divided by addition 3 plus 3. Tell me 3 into 3, 9. 3 plus 3, 6. 9 over 6. You can cut it. You can cut it. If I divide 9 by 3, it is 3 ohm. 6 by 3, it is 2 ohm. 3 over 2, how much? 3 over 2, how much? 1.5 ohm. If there are any new students, those who didn't join from the beginning, listen. If there are two resistors in parallel, you can directly find equivalent resistance. You use this only for MCQ questions. For essay structured essay question, you can't apply this way. There you need to find the reciprocal and do. Two resistors in parallel, one shot you can find equivalent resistance. How? You multiply the two values, divide by addition of the two values. Multiplication 9, addition 6, 9 over 6 is 1.5. 1.5 ohm. Or if you want, you find it in the other way, no problem. Right. So that way we get 1.5 ohm. Onnu putta. Second one, equivalent resistance is 1.5 ohm. Third one, there are three resistors in parallel. 2 ohm, 2 ohm, 2 ohm. Three resistors in parallel. Now, three resistors in parallel, there is no any shortcut. You should use the normal method. Shortcut is only for two resistors in parallel. Three resistors parallel. On. 2 ohm, 2 ohm, 2 ohm. If there are three resistors in parallel, how to find the equivalent resistance? 1 over R equivalent, that's a normal method, is equal to 1 over 2 plus 1 over 2 plus 1 over 2. That gives you 2 is the common denominator, 2 over 1 plus 1 plus 3. That is 1 over R equivalent. 1 over R equivalent is 3 over 2. You want R equivalent. Turn this upside down. Turn that also upside down. That is 2 over 3. How much is 2 over 3? 2 over 3. 0 times, no, 20. 20 divided by 3. 6 times 18. Another 2 is there. 20 again 6 times 18. Another 2 is there. It keeps on continuing. 0.667. 0.667 ohms. So their equivalent resistance is 0.667 ohms. I'll directly write it as 67 ohm, 0.67 ohm. Now with the values you can tell me. With the values you can tell me. With the values. There you go. With the values you can tell. Onna putte. First setup resistance is 6 ohm. Second setup resistance is 1.5 ohm. Third setup resistance is 0.67 ohm. Where you have the lowest resistance? Where you have the lowest resistance? With the values you all tell me. 6, 1.5, 0.67. Where you have the lowest resistance? And instance 3. Lower the resistance, higher the current flow. Higher the current flow, higher the brightness. Then which instance you have the highest brightness? Which instance here the highest brightness? And instance 3. Instance 3. The bulb connected to the circuit lights with lights brightest is instance 3. Brightest is instance 3. Okay. So if you get a question like this and if you are stuck on deciding logically, best is put some values. All the values. From there you can get the final answer. On. Now going to the easy logical shortcut method. Remember, listen, remember resistors, resistors, resistance value will increase in series connection. The total resistance value will increase in series connection, correct? No? If this is 2 ohm, 2 ohm plus 2 ohm, how much? 2 ohm plus 2 ohm, how much? Dingala, tell me. 4 ohm. Series connection, resistance value increases. On parallel connection, 2 ohm, 2 ohm, 2 ohm, 2 ohm. Do and tell me what's the equivalent resistance? What's the equivalent resistance? Use the shortcut. 2 into 2 divided by 2 plus 2. 2 into 2, 4. 2 plus 2, 4. 4 divided by 4, how much? 1, 0. Ayyo, lamai. 4 divided by 4, it's maths. 1 ohm. 4 divided by 4, 1 ohm. So there, your equivalent resistance is how much? 1 ohm. 1 ohm is, listen, 1 ohm is even less than 2 ohm. One single resistance value. One single resistance value is 2 ohm, but the overall equivalent resistance is only 1 ohm. Increasing or decreasing? Increasing or decreasing? And decreasing. So always remember, you have one single resistor, it will have a certain resistance value. When you connect them in series, overall resistance will increase, equivalent resistance will increase. If you connect them in parallel, do the calculation and see. If you connect them in parallel, equivalent resistance, REQ can equivalent resistance, those are basics, grade 10 work. REQ can equivalent resistance. Equivalent resistance will decrease. See, here you are getting 1 ohm. Here you are getting 4 ohm. 4 ohm is greater than 2 ohm. 1 ohm is less than 2 ohm. Keep that in mind. Series connection, equivalent resistance increase. Parallel connection, equivalent resistance decrease. The more and more you connect parallel, the more and more the equivalent resistance will decrease. More and more you connect parallelly, more and more equivalent resistance decrease. Now you connect, let's take 3 like this. Equivalent resistance will be even less than 1 ohm. You connect 4 like that, equivalent resistance even less than that. The more you connect parallelly, more it will decrease. The more you connect them series, more it will increase. Series connection will increase the equivalent resistance. Parallel connection will decrease equivalent resistance. Series will increase, parallel will decrease. Now, paper class students, they know. You all should know. Can remember, I think third paper, hari, fourth paper, hari, we discuss about it. So remember that. Single resistor, it will have a certain resistance. Series connection, equivalent resistance increase. Parallel connection, equivalent resistance decrease. So that they tell me, without any values, Dingala tell me one shot where you have the lowest resistance. Now without values, tell me where you have the lowest resistance. And third. It's a 1 second question. If you know the logic. It's a 1 second question. Hello, sir. Someone told that O-level science paper will be harder this time because new government will be that much of hard like A's turn to B. A's turn to B. Science paper will be hard. You can't expect your final O-level exam to be very much easy. That's for true. Then that there's no standard, no lamai. Final O-level exam, it should have a certain standard. They can't go above that standard also. It's unfair. They can't go above the standard. They can't go below the standard also. Your paper will never be hard. It will never be easy. What we can only tell is it's a standard paper. That's it. Now, last year O-level paper, it was not that much standard. If you look at the marking, we did the paper. So many questions they gave free marks or 2 3 answers correct. If you look at MCQ questions and all, it's not that standard. So what we can discuss about a paper is only the standard, not hard, not easy. It will be to a certain standard. Whatever the paper you get, let's say from your end you feel hard, from your end you feel easy, whatever it is, only two options are there. You might feel it is hard, you might feel it is easy. Whatever it is, you play the game. Whatever they give at that moment, nothing to do. Whatever they give, hurry, hard, come on. Now hard kila, just thinking it is hard, wasting your time on it, the paper got hard, what to do. Instead of thinking on that, scoring on easy questions there is more better. No? Maybe 1 or 2 questions will be hard. Now 2019 paper, maybe that year the students, those who were doing, maybe this question they would have felt it hard if they don't know the logic. Maybe this question they would have felt it hard. That doesn't mean full paper is hard. Look at the other question. Even this question carries that same 1 mark. This question, first question carries that same 1 mark. So that doesn't mean this paper is hard. Only thing, some places you get hard question. That doesn't mean full paper is hard. So you can't expect all the questions to be hard. They are a scoreable section. So you score scoreable section. Let's take you are a 2019 O-level student and you don't know how to answer this question. What would I recommend best is keep this question. If you don't know anything, you have zero knowledge on it. Hurry. Keep this question. Maybe put a mark. Keep this question. Score on the other question. Look at the other question. On 19th question. Now you have joined to Chem Night. Now you know the answer. Answer it. Like that, whatever the section that you can score and go first. May can know which polysaccharide contain in plants help to prevent constipation. Can double one shot. What polysaccharide contain in plant help to prevent constipation? Constipation. What is avoiding? Cellulose. Dingala, these questions you can answer and go. So whatever the questions that you can score. It's like a test match. This is not like 2020. Each and every ball counts. At least with 1 score, you can score. You don't need to hit sixes for all the questions. Huh. So answer is answer 3, instance 3, right? Next, we will go to question 17. Next, we will go to question 17. Question 17. Given below is the balanced equation relating to the decomposition of potassium permanganate. Balanced equation is given. 2 potassium permanganate turns to potassium manganate, manganese dioxide, oxygen. Right. Now it's a balanced chemical equation. It's a balanced chemical equation. Right. What are they asking? How much is the amount of moles of potassium permanganate how much is the amount of moles of potassium permanganate that should be decomposed to produce 3 moles of oxygen. Produce 3 moles of oxygen, how much of potassium permanganate should be decomposed? On. It's a stoichiometry based question. Question 17 of 2019 O level is stoichiometry based question. Stoichiometry based question. This word is not there in our syllabus, but this section is there. This section is there. Listen. What do you mean by a balanced chemical equation? Now, until now, you would have practiced balancing. When you get chemical equation, you would have balanced it. What does that balanced chemical equation tells us? It should tell us something. It should tell us a story. Chemistry, everything tells us a story. What does balanced chemical equation tells us? Now, I'll write an equation. Now, let's take carbon reacting with oxygen. I'll take sodium reaction. Sodium reacting with oxygen forming sodium oxide. A simple reaction. We'll balance it. 2 sodium are there. To balance it, what we put a 2 there. First we will see. 2 sodium are there. To balance it, we'll put a 2 here. Sodium story done for now. Look at oxygen. 2 oxygen are there. To balance it, in front, what you should put? This side 2 oxygen are there. To balance it, in front you need to put 2. Oxygen story done. Again, sodium, there's a problem. This side we have 4 sodium. To balance it, you have to put 4 here. To balance it, you put 4 there. This is the balanced chemical equation. What does this balanced chemical equation tells us? Listen, now listen very carefully. What does this balanced chemical equation tells us? Onna puthi 4 moles of sodium will react with, now in front there is no number, means what is the number there? If you don't write a number in front, what is the number there? 1. Will react with 1 mole of oxygen and produce 2 moles of sodium oxide. That's the meaning. 4 moles of sodium reacts with 1 mole of oxygen producing 2 moles of sodium oxide. 4 moles of sodium with 1 mole of oxygen produces 2 moles of sodium oxide. That's the meaning of this balanced chemical equation. Can you say it tells us a ratio connection? 4 reacts with 1 producing 2. 4 with 1 produces 2. It's a ratio connection. 4 with 1 produces 2. Ehenang y'all tell me. 8 moles of sodium. Now this side I make it 8. 8 moles of sodium needs how many moles of oxygen? Think mathematically. 4 moles need 1 mole. Then 8 moles needs how many moles? Mathematically think. 8 mole needs how many moles? 1, 2 moles. 4 needs 1, 8 needs 2. And produces how many moles of sodium oxide? How many moles of sodium oxide? And 4 mole produces 2 mole. Then 8 mole produces 4 mole. The ratio concept. It's a ratio concept. 16 moles of sodium reacts with how many moles of oxygen? 16 moles of sodium needs how many moles of oxygen? 4 moles. 1:4 is the ratio. Sorry, yeah. 4:1 is the ratio. If 4 comes here, 1 comes there. If 8 comes here, 2 comes there. Then if 16 comes here, 4 should come. And produces how many moles of sodium oxide? That is half of it. 4:2. Half of it. So if 16 comes, that side how much will be coming? 8 moles. 8 moles will be produced. So basically, Balanced chemical equation gives us a ratio. That ratio is called a stoichiometric ratio. So this is stoichiometric ratio relationship. It gives us stoichiometric ratio relationship. It's something like this. When you are making cake, mm, right, let's say you are making butter cake, right, after after your O levels, right, now don't go to make butter cake. After O level, now O levels are done, right, now you are in your April season, right, the real New Year, right, all real celebrations are there. April, me, April for 2025 O level batch කියන්නේ superb April, right. So April has started. Now, now it can say usually what people do is, tradition is people will go on trips. That's for sure. I think can't avoid. It's unavoidable thing. Yeah, it's a tradition, right? People go on trip. All level people, all level exam. It's a traditional thing. Right? Then trips sticker, right? Trips done. After 1 week, you also get bored. Right? Now you think after all level, I'm not going to do anything. I'm going to just stay here. Right? Right? Sleep well. I think only 1 or 2 days you will be sleeping. After that, you also get bored. Mm. You try to attend classes. You necessarily try to attend classes. So now, the trip story is also done. After that, now some boys, what they do is the tradition is they start growing hair. Go to a gym, right? Particular boys will be doing on one side. Normally, yeah, I'm telling the normal condition. Normal Homo sapien does like this after level. Girls, what they do is they start watching some YouTube video and try to make some cookery things, right? Cake, the siblings only have to test the cakes. So they start making some cake. Mm. We also get so first batch of cake I have made. Can you taste and tell? Gila, some people bring us also and give. Good, right? Whatever I have got good cakes, right? Cakes, brownies, same they gave. That's good. However, now let's say you're making cake now. You have watched a YouTube video, Indian video, that fellow is making a cake. Now, one guy is telling you to make butter cake, to make butter cake. To make 1 kilogram of butter cake, he is telling you to use 8 eggs, 500 grams sugar. Sorry, don't believe me. I don't know the recipe. Don't look at this and try to make. And I'm just imagine, right? Imagine to make 1 kilogram of butter cake. That fellow is telling you use 8 eggs and 500 grams of sugar. Right? You put sugar in it, sugar or icing sugar, whatever. I know the sugar should be put there. Sugar, icing sugar, whatever. Okay, whatever you put. So 8 eggs and 500 grams of sugar to make 1 kilogram of what you call butter cake. Now this is what YouTube guy is telling you. Now you're not satisfied with 1 kilogram. You wanted to offer it to your whole village. Your first batch of cake, whole village should eat. Harid, I thought you are planning to make about 3 kilogram of cake. Me. You are trying to make 3 kilogram of cake. Your final output should be 3 kg. Now you all tell me using your mathematical knowledge, using your stoichiometry knowledge, as a student who has done O level, who has learned science, tell me how many eggs you need to use? How many eggs you need to use? Ah, you need to use 24 eggs. How much of grams of sugar you need to use? Tell me in grams. How much of grams of sugar you need to use? And 3 times of it, 1500 grams. Same thing I was teaching all this time. Same thing I was teaching all this time. To get 2 moles of sodium oxide, you need 4 moles of sodium. Then to get 8 moles of sodium oxide, you need how much of sodium? 16 moles. Understood? Understood? When it comes to food, we understand better. I know you, Puta. Hari? So that's the story there. That is the stoichiometric relationship. To get 2 mole, you need 4 mole here. Then to get 8 mole, you need 16 mole. That ratio is only given by stoichiometry. Now go to the question. Now, hereafter never get this question wrong. Given below is a balanced equation relating to the decomposition of potassium permanganate, KMnO4. Look at the equation. Look at the equation. 2 moles of potassium permanganate decomposed to form. Now, no number can 1 is there. No number can 1 is there. Look there. 2 moles of potassium permanganate decomposed to form. 1 is there. 1 mole of potassium manganate. No number. Then 1 mole of manganese dioxide. No number. Then 1 mole of oxygen. What's the question asking? How much is the amount of moles of potassium permanganate that should be decomposed to produce 3 moles of oxygen? Now already YouTube fellow has given you the ratio. Now you are going to make 3 moles of oxygen. Then you all tell me, to get 3 moles of oxygen, how many moles of potassium permanganate you need? How many moles of potassium? Oh, everyone answer now. How many moles of potassium permanganate you need? 2 mole, 1 mole. To get 1 mole, you decompose 2 mole. Then to get 3 mole, how much you decompose? Thrice of it, 6 moles. Sorry, twice of it, 6 moles. What's your answer? What's your answer? Answer is answer. Never get it wrong. This answer. Okay. Right. Right. Huh. Next, I will finish off 15th question. Yeah. 15th question. The movement of an object during 25 seconds is illustrated in the velocity time graph. Select the correct statement about the movement of the object. Onnapute, y'all tell me. Y'all tell me. Y'all tell me. VT graph. That is question number 15. Question number 15. VT graph. What are the basic logics you should know in a VT graph? In a VT graph, if you get a slanted line upward, what does this mean? Time is going, velocity increasing. Time going, velocity increasing kyanne acceleration. And if it is a straight smooth line, it is uniform acceleration. In a VT graph, now think opposite. If the graph goes down like that, what should be that? Up is uniform acceleration, the down is uniform deceleration. Uniform deceleration. In a VT graph, if you get a straight line like this, what does that mean? What does that mean? Not rest. Not rest. What is that? It has a certain velocity. See, it has a certain value in y-axis. Let's take 25 meters per second. It has a certain velocity. Is the velocity increasing? No. Is the velocity decreasing? No. Then what velocity? What velocity? Uniform velocity or constant velocity. Uniform velocity. That's what you should understand. It's not at rest. It's not at rest. It has a certain velocity, but uniform velocity. Uniform velocity. Okay. Okay. Next, area under the graph. What does the area under the graph gives us? Area under the VT graph gives us displacement. Area under VT graph gives us displacement. What does the gradient of VT graph gives us? Gradient of VT graph gives us, gradient is the slope. Acceleration. These things we have already done deeply. Acceleration. Now go to the question. Go to the question, Puta. The movement of an object during 25 seconds is illustrated by the VT graph given. Select the correct statement about the movement of the object. I will keep the first answer, then I'll go to the other answers and come back. To the other answers and come back. Second answer. Displacement of the object is 0. In a VT graph, area under the graph gives us the displacement. Look at this graph. It has an area under the graph. If there is area under the graph, it has a certain displacement. Can the displacement be 0? Can the displacement be 0? Never. There is an area. There is a visible area here. If there is area, there is a displacement for sure. So there can't be 0 displacement here. It has this. This is wrong. Third, acceleration of the object is 10 ms to the power minus 2. First tell me, in this graph, I'll break the graph into 3. A, B, C. Which part of the graph has an acceleration? Which part of the graph has an acceleration? A part. Only A part has acceleration. Now forget about all the others. Only look at A part, this part. Only look at A part. What's the final velocity? 10. Final velocity 10. What's the initial velocity? 0. How much is the time taken? 10 seconds. We'll calculate acceleration. Acceleration is final minus initial velocity divided by time. Final velocity is 10. Initial velocity is 0 divided by time taken is 10. That is 10 divided by 10. How much? 10 divided by 10. How much? 1. 1 ms to the power minus 2. Acceleration is 1 ms to the power minus 2. The acceleration of the object is 10 ms to the power minus 2. Not 10. It is 1. We calculated and 1. Acceleration is 1. Fourth question. The fourth statement. The object has moved 20 seconds at a velocity of 10 meters per second. 20 seconds with 10 meters per second. It is moving at 10 meters per second. That velocity is there. That's a constant velocity graph. It has moved at 10 meters per second velocity. See, it has moved at 10 meters per second velocity, that part. But how long it has moved? How long it has moved? How many seconds? Not 20 seconds. 20 seconds is from 0. Only this part of the graph is 10 meters per second. That part of the graph is how many seconds? 10 seconds. So only how many seconds it has moved at 10 seconds? 10 seconds. Only this part of the graph. That is 10 seconds. Only that part of the graph. 10 seconds. So the object has moved 20 seconds at velocity 10 meters per second is wrong. All those three are wrong. Now read the first. Now read the first one. Retardation of the object is 2 ms to the power minus 2. Retardation means deceleration. Retardation is deceleration. Look at the graph. Look at the graph. Which part of the graph has a retardation? Which part of the graph? C. We'll calculate the retardation. We'll calculate the retardation there. Now look at only this part. Only look at that part. Nothing else. What's the final velocity? Finally, object is coming to what? What's the final velocity? What's the touchdown velocity? 0. Touchdown velocity 0. What's the initial velocity? 10. Initially at 10, going to 0. How long it is taking for this motion, C part of the motion? How long is it taking for only for C part of the motion? 5 seconds. We'll first calculate acceleration. If you get a negative acceleration, that is deceleration. We'll calculate acceleration. If you get a negative acceleration, that is deceleration. Acceleration is final minus initial velocity divided by time. Finally, touchdown velocity is 0 minus initially at the starting of C, motion C, initial velocity 10 divided by the time taken for that motion is 5. That is minus 10 over 5. What is the acceleration? Minus 10 over 5. How much? Minus 2 ms to the power minus 2. A negative acceleration is positive deceleration. Negative acceleration is positive deceleration. Negative 2 ms to the power minus 2. Then what is your deceleration? 2 ms to the power minus 2. That's your deceleration. The deceleration is 2 ms to the power minus 2. I guess that's what the first statement is telling. Retardation of the object is 2 ms to the power minus 2. Correct. Retardation is 2 ms to the power minus 2. Retardation 2 ms to the power minus 2. That's correct. So your answer is answer 1. Okay. Next we'll finish off question 11. Next we'll finish off question 11. The acceleration due to gravity on Earth's surface is 10 ms to the power minus 2. Acceleration due to gravity on Earth's surface is given. Acceleration due to gravity on the surface of Moon is 1 over 6th acceleration due to gravity on Earth. See? Question 11. Acceleration due to gravity on Earth is given 10 ms to the power minus 2. And what are they telling? Acceleration due to gravity on surface of the Moon is 1 over 6th acceleration due to gravity of the Earth. 1 over 6th acceleration due to gravity on Earth. Acceleration gravitational acceleration on moon is 1 over 6 the acceleration due to gravity on earth. 1 over 6 the acceleration due to gravity on earth. Agree with my equation? Acceleration due to gravity on moon is 1 over 6 the acceleration due to gravity on earth. Mathematically, is it correct? Did I correctly convert the sentence into the equation correctly? See, acceleration due to gravity on earth is this amount. Acceleration due to gravity on moon is 1 over 60 acceleration due to gravity on earth. 1 over 60 acceleration due to gravity on earth. So if I write it with numbers and key, acceleration due to gravity on moon is 1 over 6, g on earth is 10. I'll keep it as it is. I'll keep it as it is. This is the first one, this is the second one, right? G values are given. If the weight of man on earth is 600 Newton, how much is his weight on moon? Man is there. On earth, weight of this man on earth is 600 Newton, it seems. They are asking weight of this fellow on moon. After the exam, he has gone on a trip to moon. They are asking what is his weight on moon. They are asking what is his weight on moon. We'll try to calculate. Weight on earth is 600 Newton. From this, can't you find the mass of this person? From the weight on earth, can't you find the mass? Can. We'll first find the mass. Weight is equal to mass into gravitational acceleration. Weight on earth is 600 Newton. That is equal to mass into gravitational acceleration on earth. You don't need to write the equation. One shot you can tell. Weight is 600 Newton. Mass you don't know. Gravity on earth is 10. Dingala, tell me, what's the mass? One shot you should be able to tell this. No need to write the equation. What's the mass? 60 kg. Mass is 60 kg. Mass of this fellow is 60 kg. Remember, whatever the planet you go, your mass doesn't change. Mass is the amount of substance inside you. That can't change. You going to moon, you going to Jupiter, you going to Saturn doesn't mean your mass, amount of matter changes. Wrong. Amount of matter doesn't change. It is never changing. Unless and otherwise you lose your mass on the way, right? You eat a lot and become fat. Otherwise, your mass is the same. You can't change your mass. You going to moon doesn't mean you become thin. You going to Jupiter doesn't mean you become fat. So your mass is the same. On Earth, wherever you go, your mass is the same. Your weight will only change. Only your weight will change. So your mass is 60 kg. Wherever you go, your mass is 60 kg. You're going to moon now. They are asking what's the weight of you on moon. Weight on moon is equal to mass. Mass is a constant. Mass cannot change. Into gravity on moon. Mass into gravitational acceleration on moon. Now apply the values. Weight on moon is mass is 60 kg multiplied by gravitational acceleration on moon, we know 1 over 6. I'll write without units into 10. Now maths. Now maths. Cut off. 6 and 60 cancel off. 10. 10 into 10, how much? 10 into 10, how much? 100 Newton. So your weight on moon is 100 Newton. Okay. On a shortcut. Listen, no need to do all these things. On a shortcut. Your weight on earth is 600 Newton. When you go to moon, gravitational acceleration is 1 over 6. The gravitational acceleration on earth. then your weight also becomes 1/6 of the weight on Earth. Gravitational acceleration is becoming 1/6 the gravitational acceleration on Earth. Then your weight will also become 1/6 the weight on Earth. Weight on Earth is 600 Newton. You all tell me 1/6 into 600. How much? 1/6 into 600. How much? 100. One shot you can get the answer. Whatever the proportion that is happening to the gravitational acceleration is the same proportion that will happen to your weight as well. Now let's take, just imagine you are going to Jupiter. Gravitational acceleration on Jupiter is 3 times the gravitational acceleration on Earth. Ehema they are telling. Gravitational acceleration on Jupiter is 3 times the gravitational acceleration on Earth. On Earth, your weight is 600 Newton. Then you all tell me on Jupiter. One shot tell me without any calculation. On Jupiter, what will be your weight? Gravitational acceleration on Jupiter is 3 times the gravitational acceleration on Earth. Your normal weight on Earth is 600 Newton. If so, on Jupiter, what's your weight? On Jupiter, what will be your weight? 3 times of it. 3 times of 600 is 2400 Newton. So whatever the proportion that is happening to your gravitational acceleration is the same proportion that is going to happen to the weight as well. Not 2400. 3 times of it, 1800. 1800. So whatever that is happening here is the same thing that happens there. Huh. So here they are asking how much is his weight on moon. One shot tell me. Gravitational acceleration is becoming 1/6 the Earth. Then weight will become 1/6 the Earth. Weight is 600 on Earth. Then on moon how much? Moon how much? 100 Newton. Moon becomes Newton. On those 3 questions I have discussed the depth, maximum depth I can go. Again, you can't get those 3 questions. 4 questions. 4 questions. Resistor question, stoichiometry question, V question, and acceleration due to gravity question. 4 questions. What a depth we have gone. See, 4 questions we have discussed almost for 1 hour. Again, you can't get these types of questions wrong. Never. Understood those 3 questions? Yes. Clear. Now we'll go in normal order. 11th question done. Deficiency of following vitamin causes anemia. Anemia, what's a vitamin? That's a direct theory question. Anemia, what's a vitamin? Vitamin B. Answer 2. Answer 2. Question 13. In which part of the female reproductive system does fertilization occurs in human reproduction? Where does fertilization occurs? Where does fertilization occurs? Question number 13. Question number 13. Where does fertilization occurs? Remember, remember, fertilization occurs at fallopian tube. Fertilization occurs where? At fallopian. Fertilization occurs at fallopian tube. F and F connecting tube. In which part of human reproductive system does fertilization occur in human reproductive system? Fallopian tube. Answer 3. Question 14. Question 14. What is the mass of glucose required? They are asking the mass. That's also a calculation question. To make 500 centimeter cube, volume is given, of glucose solution of concentration 1.0 mole per decimeter cube. Relative molecular mass is also given. Concentration is there, volume is there. C is there, V is there. That's question number 14. Question number 14. C is there 1.0 mole per decimeter cube. V is there 500 centimeter cube. They are asking you the mass. First tell me from C and V what we can find first. From concentration and volume what we can find first? Moles. We can first find number of moles. When you know number of moles, they are given the relative molecular mass also. Job is easy. Can't you find the mass? Can't you find the mass? Yes. So now that map should be processing in your mind. How you are going to do the question? Right. First we'll find the number of moles. C equal N over V. You need to find N, subject N is equal to CV. Concentration is there, 1.0 mole per decimeter cube multiplied by volume is 500 centimeter cube. You all tell me. Using centimeter cube, can we do this question? No. Using centimeter cube, you can't. You need to convert centimeter cube to decimeter cube. What's the shortcut I taught you? In Chemnite, I have taught you. Centimeter cube, take it like gram. Decimeter cube, take it like kilogram. Tell me, 500 grams. How many kilograms? How many kilograms? 0.5 kilogram. Then how many decimeter cube? 0.5 decimeter cube. So that is 0.5 decimeter cube. So from there you get decimeter cube per decimeter cube cancel off. 1 into 0.5 is 0.5. That is 0.5. Question not done. From there you need to find the mass as well. Now apply the second equation. Number of moles is equal to mass over molar mass. Need to find the mass, then subject mass, molar mass goes to the other side. Mass is equal to number of moles into molar mass. Number of moles is there 0.5 moles. Multiplied by relative molecular mass is given 180. And can you remember yesterday I taught you relative molecular mass no unit. That's why they have given without any unit. Relative molecular mass no unit. Without any unit they have given 180. But what you are writing here is molar mass. Molar mass has a unit. What's the unit? Yesterday's work. Molar mass has a unit. What's the unit? Gram per mole. So that is, if I properly write, I'm doing it like a essay question. You can do this in your mind. That is 180 gram per mole. Half of 180 is how? 90 moles. 90 moles. That is answer number 2. Answer number 2. Hari. Sorry. That's not moles, no. It should come in what? Moles per moles cancel off. You get the answer in grams. 90 grams. Okay. So your answer is answer 2. 14th question done. 15th question done. 16th question. 16th question. In which part of the alimentary canal is the enzyme lipase added to the food? Remember, lipase. Lipase is added to the food through duodenum area. Through which part? Duodenum area. Answer one. Answer one. 17th question done. 18th question also done. 19th question. Consider the following chemical substances. Alimentary canal. Alimentary canal means your digestive tract. Consider the following substances: solid sodium chloride, molten sodium chloride, aqueous sodium chloride. Which of the above conduct electricity on chemistry night question? Which can conduct electricity? Ionic compound in aqueous medium, ionic compound in molten fused state, aqueous acid, aqueous bases. Solid sodium chloride. Did I teach anything like solid substance can conduct electricity? Solid ionic compound can conduct electricity? So solid sodium chloride, wrong. It can't conduct electricity. Molten sodium chloride, yes. It is fused ionic compound can conduct electricity. Aqueous sodium chloride, aqueous state of ionic compound, yes, can. B and C, what's your answer? B and C, what's your answer? Answer 3. Answer 3. 16th question. Did we skip any question? 16th question here, duodenum is the answer. 16th we did. Duodenum. So there the answer is answer 3. Question 20. When supplying electricity to an electronic equipment, it may get damaged if the source of electricity is connected to it with the terminals reversed. Which diagram illustrates correctly how a diode should be connected to protect the equipment from such a damage? Right. That comes under uses of diodes. Electronics question. Electronics question, uses of diode. Now, if you take DC current appliances, direct current appliances, it has a positive terminal. To the positive terminal, you should connect the positive terminal. To the negative terminal, you should connect the negative terminal. This way only you should connect it. Then only the appliances work. Let's take, you connect it by inverted terminals. You connect it in opposite way. It will get damaged off. When you connect negative to positive, positive to negative, device will get burnt off. DC current appliances, if you connect it in inverter terminal, surely it will damage, most of the time it will damage the device. How to prevent from this damage? How to prevent from this damage? You can use a diode. You connect the diode this way. You connect the diode that way. Look, you connect the diode that way. When you connect the diode that way, now see, if you connect this circuit in correct way, if you connect it in correct way, can the current flow? We'll see. Current will flow from positive to negative. Current comes. Current comes. Current comes. I have already taught you the shortcut. Current is first meeting the arrow. It will go or not go. Current is first meeting the arrow. It will go. Remember, in the diode, if current first meet the arrow, it will go. Current will go there. Current will go there. Current flows through the DC appliance. Current goes there. Current goes there. Current goes there. Circuit is completed. Device will work. Proper connection, device works. There is a current flow. Just imagine if you connect it in inverter terminals. If you make the connection in inverted terminal. This way you connect it. Now it is inverted. Positive connected to negative, negative connected to positive. If you connect it like this, let's take, if current tries to come, current won't come. If current tries to come, current comes, current tries to flow through the device, trying. Current is meeting the gate first. Can the current go? Can the current go? No. If the current can't go, will there be a current flow? Will there be a current flow? No current flow. Current won't go. There will be no current flow. If there is no current flow, will the device get damaged? Will the device get damaged? And no, it won't get damaged. So basically, you can protect a DC current appliance from the damages due to inverted terminals by connecting a diode in this way. That way you connect the diode, you can protect. The question is from that section. Which diagram illustrates correctly how a diode should be connected to protect the equipment from such a damage? What's your answer? What's the answer? First one, Neil. Answer is answer. Okay. Clear with all the questions? Top hit questions, 2019 second set of MCQs. So can you name which year has the best oral paper for science in this year, this syllabus? I would tell 2019 super. We are doing 2019 paper, 16 paper, part 10, 16 paper, 15 also. 15, it's not fully new syllabus. 15 also touches part questions. And you are in those three papers finish off until essay questions. 2019, 2016, 2015. They have deep science. But if you want to understand the pattern, now you all are 2020 full level batch. For you to understand the pattern, best is do 3 years before that. 2024 batch, then do 2023 paper, 22 paper, 21 paper. Then you will and you can analyze the pattern. You know the pattern, how the pattern is going to be. Okay. Right. With that, we are done with our second set of MCQ. This week, MCQs are done. Saturday, Sunday, however, we don't have the session. Again, I'll be meeting you on Monday. That is after 2 days, I'll be meeting you all. Time is counting. Clock is tickling. Now, don't even think of reversing back. Don't even think of keeping a step behind. You're already marching forward. Now, increase your speed. Walk forward. Don't even think of reversing back. Don't even think of giving up. Right? Thoughts will go. Thoughts will go automatically off the mind. But tell to yourself, no, I'll be constant on this. I need to work motivated. I need to work focused onto this. So work. Last few weeks we are counting on. Not that you can't, not that it is hard. You all can. That's why you all are running until now. You all are waiting all this time just to go through this 10 MCQ, put the things to the mind. You are working on all these things because inside you there is something that is sparking you to somehow do this in the best way you can. Don't lose that. Don't give up on that. That is the strength that is keeping you all running. Keep on running with same strength. Don't stop until the end. Don't get into some unnecessary thing. These days, work properly. Right? Focus on this. All of you can. Right. Okay. Enough for today from my end. Y'all keep working. I'll meet y'all after your hard work on Monday.